Today's reading, I will be paraphrasing from a children's reading by Carolyn Fisher entitled The Microbes and the Planets. Did you know that there are trillions, yes, trillions of little tiny creatures living inside your bodies? They're called microbiota, and they're so tiny that to them, you and your body are like a planet. To the microbiota, I am Planet Sarah. That is Planet Chalice, Planet Craig back there, and Planet Dylan way in the back. Woo! We're all little planets. Microbes are so tiny that you can't see them with the naked eye. You can't hear them and can't feel them move. One microbe all by itself can't do too much. They live in your planet body and depend on you for their entire lives. But your planet body also depends on them to stay healthy. If the microbiota are out of balance, you are more likely to get sick. Have you ever been sick? Of course, we've all been sick at some point in our lives. You might have had a fever. Maybe you threw up. Maybe you had the sniffles. All number of things can happen. When this happens, it might be because the microbiota in your planet body got a little out of balance. Some microbiota protect you from other bacteria that make you sick. Other microbiota help digest your food and do other things within your bodies. In general, if you are healthy, you can thank all those trillions of tiny microbiota working together to keep things in balance. So our bodies are like a planet, but our planet, Earth, is also like a body. And people are like one kind of microbiota. I am Microbe Sarah. That is Microbe Chalice, Microbe Craig, Microbe Bill. We're all little microbes on this great big planet. And most of the time, our planet Earth is so big and we are so tiny compared to it that we don't even notice or remember how much we depend on our planet. For the air we breathe, for the food we eat, for the water we drink. But just like the microbiota in our bodies, our planet Earth also depends on us. Just like your body depends on your microbiota to stay balanced and healthy, our planet Earth depends on people to stay balanced. You probably know that our planet Earth is not very healthy right now. And this is because people have been out of balance. Sometimes this feels like a really big problem for one little microbe like me. Our planet Earth is so big, but together with lots of other people, we are working to get our planet Earth back into balance. And we can do little things like biking or walking instead of driving. We can recycle or reuse our waste. We can do medium things too, like going to meetings with government workers or talking to people about how important it is to put things back into balance. And sometimes we can even do big things too. Our planet Earth is sick, and each of us are just tiny, tiny little microbes. But when we work together, we can push the balance of our planet Earth back towards being healthy. And now I have a wonderful, but kind of fun song all about microbes that Dylan is going to play for us. This is called the Bacteria Song by Peter Weatherall. Please enjoy.
We only have one cell, and inside each of us, there aren't any organelles or a nucleus.
more.
Sorry.
Buffering. You can do it, computer. I promise it's a really fun song.
All right, we're gonna stop that.
We only have one cell, and inside each of us, there aren't any organelles or a new.
Well, now I'm very sick. It's a very catchy tune. I'm guaranteed to be in your head all week.
Oh, you have to share the link on our.
I know. It's such a great song, you guys.
We are making up because we are prokaryotic. We only have one cell, and inside each of us, there aren't any organelles or a nucleus. We are bacteria. How bad do you? We're quite exotic. We are bacteria because we are prokaryotic. Some of us are tiny rods known as bacilli. Some of us are tiny spheres such as streptococci. We are bacteria. Compared to you, we're quite exotic. We are bacteria because we are prokaryotic. We're so small you'd hardly even notice that we're there. But there are trillions of us spread out everywhere. Find us in your gut and also on your skin. Mostly we are harmless, but some are pathogens. We are bacteria. Compared to you, we're quite exotic. We are bacteria because we are prokaryotic. We're so small you'd hardly even notice that we're there. But there are trillions of us spread out everywhere. We are bacteria. Compared to you, we're quite exotic. We are bacteria because we are prokaryotic.
Tell me that wasn't the cutest song you've ever heard about bacteria. Yeah, but worth listening to, and now it will be stuck in your head all week. You're welcome. All right, we are so excited to welcome Chalice Gustaveson, who will be speaking to us today. Oh, that reminds me. I have a few bacteria jokes. What did the male bacteria say to the female bacteria? Who needs biology when we have chemistry? But I'm cheating. Okay. Why do bacteria like nitrates so much? Because they're cheaper than day rates. Oh, why don't bacteria gamble in Las Vegas? Because they believe a good flush always beats a full house. Okay. Why did the bacteria fail the math test? Because he thought multiplication was the same as division. Okay. Enough funny business. Chalice, you better get up here before I get completely booed off the stage.
Who's got the shepherd's?
I know.
Oh, goodness. All right. Let's. Oh.
You're not gonna be here?
I know. That would be pure chaos.
We thrive on chaos.
Okay, so I'm gonna go ahead and let me log in. I should have done this before. My apologies. I'm gonna log into my slides. I do have some visuals today. Let's see. It's here. And then I can share my slides. Oh. Let's see. Gotcha.
Technology is fun.
This reminds me of every single corporate meeting I've ever been to where we have to okay. All right. Dylan, can you give me a hand up here, please, sir? You're oh, here we go. Okay, I'm sharing. Never mind. Figured it out.
Perfect.
I've been to college, I promise. Twice. That's right. I have been to the college. Okay, so let me see if I can find mine. I actually need to get into my, there we go. There's my bacteria slides. There we go. Okay, my apologies. Thank you. Am I sharing? Can we see? Okay, we can, no, maybe. Oh. There we are. Can we see? Oh, we can see it. Excellent. It's a little small, but that should work. All right. Well, good morning, everyone. Thank you so much for coming out and listening to me today. Those of you who are here in person and those who are visiting us via the ether, via technology. So just thank you, Sarah, for the introduction. Yes, I am a professional nerd, and I am very excited to come and speak to you guys today about one of my favorite things in the world, which is science. I am a professional scientist of multiple flavors throughout my career, and today I want to talk about some of the lessons that I've learned from bacteria. So part of my studies have been in, when I was in school and then also as a working scientist, was in clinical microbiology. And I absolutely fell in love with the subject. I was actually very disappointed, like when I was a chemistry major, I was kind of bummed I never had time to take microbiology classes. So years later, I finally had my chance. And I have just fell in love with the subject and how something so small can wreak such havoc in the human body and in the environment. I'm also a little bit of a sadist, and so I did enjoy tormenting my husband with all the gross things that I learned at work. And so yes, I have been banned from discussing work at the dinner table. Yeah, so it's a rule in our house. And I have wonderful. The cool thing is I've had the opportunity to work as a microbiologist in a clinical setting in the hospital, and so working on patient samples and helping our doctors and physicians diagnose what is causing a problem with our patients. So as Unitarian Universalists, we actually affirm and promote our 7 principles, which we draw from our 6 sacred sources. And today I was inspired by our 5th source, which is humanist teachings, which counsel us to heed the guidance of reason and the results of science. Now, obviously, I'm biased. I'm a scientist. The 5th principle is my favorite. And so I'm going to, basically, that's where I draw my inspiration from today. So one thing, if you look at bacteria, there's 3 things that characteristics or habits, behaviors that bacteria have that we can draw inspiration from. And so those 3 things I want to talk about today are persistence, resilience, and cooperation. These 3 topics are things that we can take, use bacteria as wonderful examples of. So speaking of persistence, bacteria are the first life forms to evolve on planet Earth, and they show up in the fossil record 3.7 billion with a B years ago. And here comes the geology portion of our lecture. So Bill's gonna be excited. So 3.72. Oh, that's right. I did give Bill permission to fact check me live during our talk today. So what's really awesome. Okay, so from this time period, there is evidence of single cell life forms that grew around hydrothermal vents in the bottom of the ocean. And this is where water gets deep into the crust of the earth. It gets heated up by the magma and then it spews back out. And it creates these warm, cozy environments for life to evolve and to grow. And what's really neat is 3.7 billion years ago, you can tell the evidence of these little tubes right here. Oops, I just knocked over my water bottle. These little tubes right here, that is proof, ancient evidence of microbial life. And what happened, and the reason we found this is through plate tectonics and, geology and the Earth's crust moving. These rocks that used to be at the bottom of the ocean are now along the western edge of the Hudson Bay in Quebec. And that's where geologists found these. And what happened is they think that cyanobacteria these ancient cyanobacteria form hematite, which is that cool kind of grayish shiny metal. And they would digest iron oxides, turn them into hematite, and then form these little residual tubes as like evidence of their growth. And they behave just like similar bacteria that are in existence today, as well as later evidence of bacterial life. So 3.7 million years ago. Now, in addition, 3.5 billion years ago, we have evidence of what's called stromatolites. And stromatolites are when bacteria kind of grows in warm ocean, shallow ocean waters, and they form like these sticky mats. And then as they grow, they kind of excrete minerals, and then they form hard structures like coral almost, but it's formed back by bacteria, and they persist. And so they found evidence of stromatolites 3.5 billion years ago. These are actually modern stromatolites. This is in Shark's Bay. This is actually in Western Australia, about an hour or so north of Perth. You can actually visit these today. And so scientists studying these structures actually heavily helped people figure out kind of the conditions of how early life formed 3.5 billion years ago. And so this is the Hamlin Pool in Western Australia. It's really kind of, you can go visit. They have little walkways that are built around it, so you can kind of like stare down and watch that little bubble up. It's kind of neat. So to put this into perspective, eukaryotic cells, which we learned about the difference between bacteria and eukaryotic from the awesome video, those only showed up 1.5 billion years ago. So the first animals left the ocean and began exploring the earth only 50 million years ago. So 3.2 billion years after bacteria. So throughout Earth's history, they have survived multiple extreme environmental changes, and they actually helped cause some of those environmental changes as well. So in Earth's history, we had what was called the Great Oxidation, where bacteria learned how to process. They actually, through their metabolism, they learned and adapted and started to give off oxygen as a byproduct. Before that, oxygen wasn't very prevalent on the Earth's surface. And then the bacteria started making it, which then caused some bacteria to die off, but then others evolved and grew to survive in the presence of oxygen as well. And so they actually helped create the oxygen that most life evolved on this planet to live off of. In addition, they've also lived through many periods called snowball Earths, where there's long stretches of time where the Earth is just a big old cold ice block, mostly due to lack of volcanic activity, correct, sir? So persistence. Bacteria have been around for a very, very long time. Moving on to our next topic, I'd like to talk about resilience. Now, the American Psychology Association defines resilience as the process and outcome of successfully adapting to difficult and challenging life experiences, especially through mental, emotional, or behavioral flexibility and adjustment to external and internal demands. So again, that is adapting to difficult circumstances. One of the best lessons I learned on resilience, I learned from my microbial genetics professor, Dr. Greg Oberg at the University of Utah, and it was mutate or die. That's been my personal motto since over 20 years since I had that class. And microbes have been demonstrating this particular ability from the very beginning of their existence. So how do mutations occur in living organisms? So through changes in their DNA. Now, changes in DNA can happen through a variety of ways. You can have random mistakes, which are made while the DNA is replicating itself during cell division. Your cells in general will make copies of their DNA and then they split. And sometimes you can get single bit mutations where our proofreading abilities aren't quite there. And some of those mutations are good, some of them can be bad. You also have environmental forces, which can cause certain genes to turn on and off. This is actually called epigenetics, which is a relatively newer field of genetic study, where environmental forces can force your body to change, and you can basically turn on and off different genes in response to those environmental stimuli. And then you also have the exchanging of genetic information. That is another way that you can get mutations. Now, the exchange of genetic information in humans is called sex. Yes. And that is when an egg plus a sperm create an embryo, join together, those genes fuse, and you create a whole new embryo, then a fetus, then a baby, and then potentially a whole new person. So Dr. Oberg, again, taught us, in his humble opinion, that bacteria are better than humans because they can have sex in 3 different ways. Not just me. That's right. So they can get new genetic information in 3 different ways. They can actually absorb DNA from their environment. So there could be free floating strands of DNA in the environment that they can then absorb and use. They can also gain DNA from viruses that are specifically adapted to infect bacteria, called bacteriophages, and they will actually infect the cell, add their own DNA into the mix. And oftentimes a bacteria, if they can survive that attack, will then incorporate that DNA into their own genome and then use those genes, those proteins. And then you can also exchange what plasmids, which are little circular pieces of DNA. So 2 bacteria can come up, they can rub up against each other. They form what's called a sex pili, which is like a little tube. They poke it into the other guy, and then they swap DNA plasmids. And so that's 3 different ways that they can get this new DNA and to learn new mutations. So through this process of mutation and gaining new DNA from one another, bacteria have learned to survive and have adapted to survive in some of the most hostile and extreme environments on the planet Earth. And here are some examples. So this is the Morning Glory pool at Yellowstone National Park. And there is a bacteria called Thermus aquaticus that actually grows in this in this pool. And it can survive in those extreme temperature conditions, those hot temperature conditions. And actually what's really neat is because it's adapted to survive in this piping hot temperatures, we actually now use some of the enzymes from this particular strain of bacteria in PCR testing for DNA testing, because it can withstand the high temperatures and the high heat. Actually, Kary Mullis, who was the Nobel Prize, well, he would have won the Nobel Prize if he was wrong. He might have won it, I'm not sure, but he was a colorful dude. Anyways, he's the one that actually had the light bulb idea. Well, I need enzymes that can handle hot temperatures, and he was an avid hiker outdoors guy, and so he was inspired to use this bacteria to create the PCR testing process, which is really fascinating. There's also, on the opposite end of the temperature spectrum, we have, this is the Greenland ice sheet. We have a Cryptobacterium greenlandensis that can be found in glaciers, deep ocean waters, and inside polar ice, and it can survive in those conditions. A little closer to home, Great Salt Lake, we have Halobacterium halobium. There we go. And that can be found in extremely salty conditions that would normally like desiccate and dry out a normal bacteria. Those are found in the Great Salt Lake and also in like the Dead Sea in Israel. And then we also have, watch, this isn't this, but I didn't want to show you a picture of like the human gut, you know, with a Sunday morning. So Heliobacter pylori, this is not it yet, but Heliobacter pylori actually lives in the highly acidic human stomach. And that is actually what causes ulcers. It's a little bacteria that has these cool little flagella and it like corkscrews into the wall of your stomach and then causes an infection. And that's where ulcers come from. And the original person, he was a doctor in Australia who had this hypothesis that ulcers were caused by bacteria, and like people just laughed at him and thought he was nuts. Turns out he was right. That there are bugs that can survive in that really harsh conditions. Now this, on the other hand, this particular bacteria is called Deinococcus radiodurans. And this is one of the most radiation resistant organisms known to man. It can survive cold, dehydration, vacuum, and acid, and therefore is known as a polyextremophile, so multiple extreme loving. And it has earned the nickname Conan the Bacterium. There you go. Resilience indeed. Okay, moving on to cooperation, our third lesson for bacteria. So a cooperative behavior is one that benefits an individual other than that person performing the behavior. And the most common form of cooperative behavior demonstrated by microbes is mutualism. And this is where a behavior is mutually beneficial for the person doing it as well as the receiver. Very much this, you know, the typical you scratch my back, I scratch yours kind of scenario. So an excellent example of this type of behavior is performed by bacteria that live in the human gut. You actually have more bacteria cells in your body than you do human cells. And most of them are in your large and small intestine, and is actually mostly the largest portion of your immune system. So the bacteria within the colon, there are bacteria within the colon that can digest dietary fiber that we ourselves cannot digest. They then take this fiber, turn it into fatty acids, which are then used by multiple cell types throughout the body, including your liver. There are some species of bacteria that can take chemical compounds that are found in broccoli and turn it into colon cancer cell fighting agents. So therefore, those of us who are getting on in years, eat more broccoli, especially if you don't want colon cancer. Humans have relied on the synthesis of vitamin B12. We have relied on bacteria for that because bacteria contain the enzymes to make that essential vitamin that we ourselves do not. We do not have the enzymes to create that from the food that we digest. So another example of cooperation in bacteria is found in what are called biofilms. Biofilms are basically structures of bacteria that are formed layer on a surface, and they are ubiquitous in nature. You can find them mostly in like aquatic environments and like lakes and streams and in the ocean. And they form actually the basis of most aquatic ecosystems. They're kind of the bottom of the food chain, and a lot of things eat that and then go up the food chain. And they're usually composed of like multiple species of biofilms working together. The cool thing about the discovery of biofilms is Dr. Bill Costerton. He was a microbiologist originally from Canada. I think he's still with us. He is University of Montana up in Bozeman. He's the father of biofilm studies. He actually discovered biofilms. He got a grant to study water quality, like bacteria, water quality in alpine streams. mostly because he wanted to get paid to go hiking all summer. And so he was able to get a grant to like, oh, I'll go study alpine streams and get paid for it. And sure enough, the water quality was absolutely pure, like crystal clear, beautiful water. You know, hardly any bacteria were in the free floating in the water samples he tested. But then if you look to the bottom of the stream, there's this icky kind of green sticky film on the rocks on the bottom. And he's like, well, what's this stuff? Took it home, sampled it, grew it. Turns out it's pure bacteria. Yeah, so that's where our knowledge of biofilm comes is Bill Costerton and his desire to get paid to go hiking. So science is awesome. All right, so I became familiar with biofilms actually when I was working as a research assistant at a orthopedic microbiology laboratory at the VEA down here in Salt Lake. We were actually studying Staphylococcus aureus, so Staph A biofilms that can cause osteomyelitis. And what happens is the bacteria will get onto the surface of the bone and then it starts growing and then it causes the bone to grow in weird malformations and it causes like little spurs and weird little growths, almost look like coral. It's an extremely painful condition. And honestly, the only way to treat it nowadays is you have to go in and physically like debride the stuff. So we were trying to figure out why biofilms are so resistant to antibiotics. And a lot of it is because of cooperation. These bugs know how to work together. So within, and if you look, I have, yep, here we go. Here's a picture of a femoral implant. So this is the top of the femur. And you have biofilm formation on this implant. Bacteria love implants. They love to get onto it and infect it, which is why when you have anything implanted in your body, whether it's a pacemaker or a prosthetic, you want to make sure that the infection control procedures for your surgery are top notch. So, all right. So within mature biofilms, you have a phenomenon called quorum sensing. And this is how bacteria communicate and cooperate with one another. And they send chemical signals to each other. And this basically, it helps them coordinate growth and it coordinates the behavior of the biofilm for maximum efficiency and like growth, conservation of energy and resources. It's like they form almost like these little bacteria mega metropolises, that's the word, thank you. And where they have water channels and all sorts of little structures. It's fascinating. And so for instance, the bacteria Vibrio cholera, which causes cholera, uses quorum sensing to actually moderate its virulence during the beginnings of a cholera infection. So once the Vibrio enters your gastrointestinal tract, usually through contaminated water sources, it will immediately begin forming a biofilm along the walls of your intestine. And it continues to reproduce and spread out, and it excretes a very specific chemical signal. And once that chemical signal reaches a specific concentration, the other bacteria recognize it. And then that's when they stop growing and move on to the next stage of the Vibrio cholera infection, which is when it starts secreting toxins. And that's when things go really haywire and you get all the horrible gastrointestinal symptoms, which I won't list because we're in church. So yeah, you're welcome. Again, church, dinner table, probably shouldn't get too specific. So yeah, I mean, some of us want to go out to lunch after this. There we go. So another example of cooperation between bacteria is actually within the lungs of cystic fibrosis patients. So cystic fibrosis is a genetic condition in which your mucous membrane tissues, so like mostly your lungs, as well as your digestive tract, excrete too much mucus and it's really thick and sticky. And unfortunately, because of this, cystic fibrosis patients are very susceptible to bacteria pneumonia because you have these warm, wet lungs with all this sticky stuff in there that the bacteria can cling to, and it's just perfect breeding grounds for bacteria. And so what's interesting is there's two different species of bacteria. There's Burkholderia cepacia and there's Pseudomonas aeruginosa. And they're very common bacteria that can cause bacterial pneumonia in CF patients Fun fact, actually, a bacteria, Burkholderia cepacia Utah has its own strain of cepacia. And so it's the Burkholderia cepacia Utah strain. And this is because we have such a high prevalence of cystic fibrosis within the Wasatch Front. The prevailing theory is that because members of the local predominant religion tend to marry within the fold, they have reinforced the cystic fibrosis genes within that population. So there's a higher occurrence of it. So it also smells like wet potato pills. So I've diagnosed it once or twice, even before I put it onto the instrument to have the chemical analysis. I'm like, yep, I know what that is. So when, for instance, a CF patient gets infected with Burkholderia, it's not as bad as when they have Burkholderia and Pseudomonas aeruginosa together. Because what happens is the Pseudomonas gives off a chemical signal, which is then detected by the Burkholderia, which causes it to be more virulent and to cause more lung damage than if it was just by itself, which is interesting. So cooperation amongst bacteria, great for bacteria, not so much for us sometimes, but it's there. So at this point, you're thinking, well, that's cool, Chalice. Thanks for the science lecture. Like, how does this apply to me? Well, let's take a look at these three characteristics that bacteria have and how can we relate them to ourselves. So thinking about persistence. Persistence is fundamental to success in any arena of our lives. Growth requires that we keep trying when we hit obstacles or challenges. Without persistence, at the first sign of failure, we would throw up our hands and just give up. As we learned from watching Mythbusters, failure is always an option. However, how do we respond to that failure? Without persistence, the Montgomery bus boycott would not have lasted 381 days. Yeah. In addition, women would not have earned the right to vote. Actually, we didn't earn the right to vote. We took the right to vote because we had the right to vote. Thank you very much. That's right. And in addition, without persistence, there would be no marriage equality in the United States. And since we are all descended from microbes, every single life on Earth, without persistence, we wouldn't be here. Now moving on to resilience. Resilience and persistence go very much hand in hand. In order to be persistent in any circumstances, you have to be resilient. You have to look at those obstacles and say, okay, I'm going to mutate or I'm going to die. How do I adapt to this? The COVID-19 pandemic is an excellent example of resilience. On a national level, some countries showed amazing ability to adapt and to quick responses to the COVID crisis. For example, South Korea and New Zealand. South Korea learned from their initial unsuccessful handling of the 2015 Middle Eastern Respiratory Syndrome or MERS outbreak. And they realized the necessity for rapid testing, contact tracing, and patient isolation. And despite their close proximity to China, they only experienced 673 deaths per 1 million of population. New Zealand, on the other hand, or not on the other hand, but New Zealand as well, is an excellent example of resilience. They quickly shut down their borders. They enforced strict quarantine procedures. It was mandatory testing for any travelers in quarantine coming into the country. And their death rate was 585 per 1 million population. Whereas on the other hand, with the Trump administration, which was disorganized and inept, and if you really want to get your blood to boil, read the book Preventable by Andy Slavitz. He's a former head of HHS. You'll get so mad, you'll probably want to throw the book across the room. But yes, every opportunity we had as a nation to make the smart choice, we didn't. In contrast, our country had a total of 3,331 deaths per 1 million. Yeah. On a personal level, we all had to be resilient in the face of COVID. We all had to figure out how Zoom works. Evidently, some of us are still figuring that out. In addition, we all learned to be like Batman and not leave the house without a mask on. I don't know about you, but there's days where I felt utterly and completely naked if I walked out the door without my mask. We used to make jokes about it at work. And we're like, in addition, some of us had to learn how to work from home, and are learning to enjoy it and are still there. So, and learned how awesome it is. So there we go. So resilience, definitely a very valuable trait to have. Our third trait, cooperation. Humans too know how to benefit from the power of cooperation. Labor unions rely on this power to be successful. If I decide that I don't like my boss's policies and I go on strike, me, the individual, I'm just going to get fired. But if all of us quit or we go on strike and business comes to a screeching halt, then we've got negotiating power. They're not making money because we're not working. And then we can get to the table and negotiate. Another example of cooperation from the pandemic is actually in regards to the technology CRISPR. So CRISPR, it was actually discovered from bacteria. CRISPR is bacteria's ability to defend itself against viral DNA, as these cool enzymes that will go and chop up the DNA and then render it inert, and so it can't infect that cell. Well, humans figured out how to use that to make gene edits and to edit genomes. And these are the two teams that did it. Well, during the spring of 2020, both teams basically kind of came up with CRISPR and published. And they, since then, for the past 7 years, they were trading lawsuits back and forth, like who discovered what, and who did this, and who can patent this, and who can patent that. And it was a bit of a cat fight. So, but once the pandemic hit, they put aside their differences and they allowed their discoveries to be used openly and without any patent licensing whatsoever to anyone who's trying to fight the pandemic. And because they open sourced their technology, rapid COVID tests were developed that only took 5 minutes. And now this technology is actually being used to create rapid diagnostic testing for the developing world because it's pretty cheap and easy technology. So it's pretty cool. If you ever want to take a deep dive on CRISPR, there's a fabulous book called The Code Breakers. It centers mostly on Jennifer Doudna. Dr. Jennifer Doudna, she's at Berkeley. She was one of the leading researchers, as well as her partner, Emmanuel Charpentier. And just a fascinating book. And it's lots of scientific gossip and drama. So lots of cheese there. It's good. And the author writes kind of in the first person narrative in some of the chapters. And you can, I love it when academic writing gets salty, and you can tell, he writes about certain characters that are in this orbit, and you could tell that he just had trying to be impartial, but he couldn't. It was great. I was like, someone's throwing shade. Okay, so another example of human cooperation was the Apollo moon landing and getting humanity to the surface of the moon. This endeavor took over 400,000 engineers, scientists, and government employees in order to make this happen. And this particular story is personal to me. So in 1969, my parents were living in Los Angeles, and my mom was pregnant with my brother Daniel. There's 6 children, so family stories, the chronology is who she was pregnant with at the time. That's how we tell time in the Hemming family. And there were over at the neighbor's house watching the moon landing because they were too broke to own their own television. This was back in the day because my dad's an engineer, and this was back in the day before engineers actually got paid anything. And my dad points to that little antenna sticking out of the top of the Apollo moon lander. And he's like, see that? I designed that. And my mom looks over, she's like, told me you're working on that. My dad's great. He's great at keeping secrets because he's a quiet engineer who doesn't talk. And so there's stories he tells from things he did for the CIA. We're like, what? I'm like, what? Okay. All right, Dad, cool. He makes a great spy. Like, you can put him on any secret project because he just never talks. He just doesn't talk. So like, yeah. Anyways, so like my mom practically falls over in shock. And so like, you know, this was several years before I was born, but this story is in family lore. And I'm like, Dad, how come we never like talked about it? Like, why aren't you bragging that your antenna's on the moon, went to the moon? He's like, it's no big deal. I was one of like, you know, hundreds of thousands of engineers. And I was like, what? Oh, whatever, Dad. Okay, that's cool. You know, but anyways, cooperation, super awesome. Because again, like through this amazing amount of human cooperation and endeavor, we were able to actually get people to set foot on another planet, planetoid, technically. So in conclusion, I would like to quote Albert Einstein, who said, "Look deep into nature, and then you will understand everything better." As human beings, we like to think of ourselves as on top of the food chain, as well as completely separate from it. In modern humanity, we've created this very sterile, disconnected life from the natural world. You know, we run from air-conditioned house to car to work to the grocery store and then back again. The EPA actually estimates that the average American only spends 7% of their time outside and outdoors in nature. And this disconnection from the natural world and our non-human roommates on this planet, it robs us of so much potential opportunities for learning wisdom. And one of the reasons I love being a scientist is that it gives me carte blanche to be nosy. You know, if I stop in the parking lot and I'm looking like at a cool plant in the planter in the grocery store parking lot, you know, and I get weird looks, I'd be like, yeah, I'm a scientist. You know, actually, side note, during COVID, I actually got to use the phrase, "Trust me, I'm a scientist." Man, my moment came. I was at the quilt store and there was these two older ladies and they were talking about COVID testing and they got some facts, little, you know, they were confused about some facts, and I was able to jump in and be like, "Ladies, this is what I do for a living, you know, and I'm like, trust me, I'm a scientist." So it was great. I'm like, the student loans were worth it. So getting back on topic, give yourself permission to stop and to look at the amazing wonders of nature all around you. Get curious. Even the smallest creatures have the stories to tell us and lessons to teach. Even the microscopic ones, like our little friends. Oh.
Thank you so much, Chalice. That was awesome. All right. We're going to turn now to a moment of a more reflective moment. Please join me in our prayer for the day. Breathe in life, for life surrounds us all. We celebrate, we marvel, we are fascinated and awestruck. May we always remember that the great interweb of life encompasses both the grand and the minute, what we can see and what we cannot. May we all be blessed with a healthy immune system full of good bacteria and microbiota to keep our health in balance. May we be diligent in taking care of our bodies and the earth. May we be blessed with strength to overcome our weaknesses and wisdom to learn how to better care for ourselves and this planet. May we be strong in the face of change, unyielding against opposition, but also flexible enough to open our minds and hearts to new possibilities. And may we always strive to be more and do more, to reach new levels, not only for ourselves, but as a community. For we know there is strength in numbers. We know that when we work together, many good things can be accomplished. Blessed be, and amen. And now let us pause. We come here with our own circumstances and people close in our minds for reasons of joy or sorrow. Please take a moment now to speak their names aloud, lifting them up in our sacred space. Blessings on those named, and blessings too on those who named them. Join me now in silent meditation or prayer. May it be so, and blessed be. You are now invited to come forward to light a candle of hope, memory, or gratitude. You may also wish to drop a stone of burden or forgiveness in our sacred gathered waters. That's afterwards. It appears we do not have any water for the stones.
Oh.
But you may still light a candle. A church community is like a body, formed from the many little microbiota that work together. As members and friends of this religious community, we share our time and energy, our creativity, imagination, and vision, our talents, skills, and gifts, and all other things to create a strong working body. But this body also depends on our financial contributions to help keep everything in balance and makes real our shared vision and values. We will now receive the offering. You are invited to give generously and joyfully as you are willing and able. Nope, go back. Now please stand in body or voice and facing the center aisle, sing together the offering song printed in your order of service. From you I receive, to you I give, together we share, and from this we live. From you I receive, to you I give, together we share, and from this we live. Thank you for this generous offering. We bless it and promise to use it wisely to further the work of our church. Now please remain standing as we sing our closing hymn, number 204.
It's actually 203.
203, all creatures of the earth and sky. 203 in the gray hardback hymnal.
One, two, three.
All creatures of the earth. Wait. So we're not on time with the music. Give it a second. Rushing wind so wide and strong, wide past that sailing back down. Well, we got it in the end. That's called cooperation. We hope that you have thoroughly enjoyed the service today. Please join me now in extinguishing our chalice by saying together the chalice extinguishing words printed in your order of service. We extinguish this chalice, but not the warmth of love, the light of truth, nor the energy of action. Thank you so much for coming today. Coffee will be held that way across in the big building again. Thank you so much. Go in peace.